Okay, today we've got Marcus's Deluxe non-reverb. Appears to be 1965. And we're just going to give it a once-over and see if it needs anything or if it's ready for showtime. He plays a lot, tours with it and stuff, so it'd be great to make sure it's tip-top shape or at least know what's going on, if anything. So, just cosmetically, grill cloth is appropriately nicotine stained and little holes here and there. Logo's looking good. Front panel, knobs all appear original and in good shape. Could clean it up a little if you want, but if it's a Rode amp, which is, a little bit risky, might not be worth cleaning the front panel up too crazy. Some of these knobs don't line up perfectly, but we can adjust that if we want to get super picky. We'll check the input jacks for tightness and stuff, because that's how these inputs get their ground. Deluxe is pretty good shape. Corners are banged up a little. Looks to be original chassis strap and bolts. We'll see about the nuts. We'll make sure the handle's tight, but the handle itself is in decent shape. And similar sort of wear on the Deluxe on the sides. Pretty darn good. Little trauma down there. The speaker obviously has been replaced for this massive EV. I'm not sure how that sounds yet, but we'll find out. At least this mounting hardware for the back panel appears to be replaced. No big deal. Back panel itself, we have replaced power and standby switches. Non-original there, it appears. And it looks like they are reversed, which is maybe player's choice, so I won't flip them around before asking Marcus. The word speaker has been scratched off of external speaker there for some reason. Trem pedal, no vibrato, no reverb input, of course, because it's just a Deluxe. We'll make sure the ground switch isn't doing anything. And maybe we can make it do something if we want to, add a negative feedback bypass or something. But it shouldn't be flipping the polarity on the AC wiring. We'll check the fuse to make sure it's 2 amp max. And it is a 2 amp fuse, good. Tube complement wise, we've got some old Sylvania 6v6s, which hopefully are good. GE rectifier, is it? And let's just take a look right inside. Yeah, that's the OG pine cabinet, of course. A little bit of dust bunnies here and there, but not bad. The baffle mounting hardware seems solid. We'll check it for tightness, but there's no splits or anything. Tube chart, of course. And the baffle board itself is correct and isn't showing signs of dampness or weakness that I can see yet. Maybe once we get these panels off, we'll get a better look. But yeah, in general, pretty good shape. Probably the finger joints there are a little bit getting old and tired, but I don't hear any squeaky squeaks. Let's just check the bottom, see if the feet are hanging in there. We got 1, 2, 3, 4 feet plus another little foot here, which I have not seen before. Anyway, kind of interesting. A little bit more Tolex wear there. Anyway, so exterior inspection complete. Nothing too weird except maybe these power and standby switches being replaced and possibly upside down according to the labeling on the switch tag here that somebody's got. Obviously normal operation for a Fender would be both of them are off at this point, then this is on, standby is still on, and then play mode there. Anyway, we'll get to the bottom of that. Replaced speaker jack, speaker plug and cable, which seems to be fine. Okay, so maybe what I'll do is just plug into it and just get a little baseline of if there's any weird hums or buzzes or what's going on gain wise and stuff, and then we'll open it up and take a look inside. All right, so power's on, and as suspected, the switches are both upside down. So I'll take it out of standby now. General noise floor is extremely quiet with all the volumes down. There's no third gain stage in the Deluxe non-reverb, so you would expect it to be a little quieter, but that is very nice and quiet as far as hiss goes. Yeah, pretty darn quiet. Let's make sure it actually makes sound. So crank up vibrato channel. Oh yeah. That's just my guitar being close to the transformer here. So, you know, when it's dimed. So a little crackle and stuff going on, probably a preamp tube. Tiny bit of bacon frying, but you know, that's on 10, that would rip your face off at normal playing volumes. It's pretty well within reason, but yeah, if you're diming it, turn my guitar down. A little bit of, so we'll find that. Maybe just a preamp tube. Or dirty socket, actually, or a dirty input jack. Let's pull the guitar completely, see how the shorting is. Same noise, no extra hum, so the shorting tipped pretty good. Let's jumper the vibrato so it comes on. And there's a pretty heavy tick. Hearing that? And if I change the speed, it goes up and down with that. So there's a pretty quick fix for that. Just adding a cap across the roach should kill that tick for you. And let's see if the trim's actually trimming. Definitely trimming. Very deep trim, actually. That's pretty cool. Very deep trim. A lot of these aren't that deep. But like most, you don't really hear it kick on much between 1, 2, 3, and then 4 it starts to come on. But it's a nice, strong trim. This pot must be swapped out though, because it doesn't do the full range. So when I'm on 1 here, and then I dime it, we only get up to 8.5. So the rotation of this pot is not stock, so I'm guessing the pot is not stock. It doesn't feel like there's any sort of mechanical resistance there. But we'll check, and maybe it has something to do with the trem depth. It is the intensity pot after all. Okay, quickly check normal channel, and then we'll power down, discharge the caps, and open it up and take a look. And we'll kill the trem. Well, let's leave it on to make sure no one's jumpered the 2 channels. No one has jumpered the 2 channels. We do not get trem on the normal channel. So that's good. A lot of gain here, which is cool. I like how this thing's sounding, but a lot of gain here could point to maybe leaky coupling cap, because essentially leaky coupling cap provides another path for DC, effectively lowering the cathode resistor value. So at stock it would be a little lower gain because it's pushing more back onto the circuit in a negative feedback kind of way. But you know, it's not crazy abnormal. These are humbuckers on a telly, so it's pretty hot input, but yeah, not way out of whack or anything. Okay, I'm gonna shut it down, stop playing amazing guitar for you, and look inside. All right, so here we are inside, and put on my granny glasses and take it for a little tour here. So we can see that the AC cable has been swapped out for a 3-conductor grounded cable. Unfortunately, they left the ground really short, which is a bit of a hazard and not code. So ideally, you want the green ground wire to be longer than the hot or the neutral, so that if this strain relief does give out and the cable gets a yank, the ones to come off are the hot and neutral, but the chassis is still grounded. So if the hot hits the ground, if the hot hits the chassis or anything, it's just gonna blow the breaker, not make the chassis live. Because if the chassis is live and you're plugged in and you're there and you're singing or anything, or just holding your guitar or touching the chassis, bad things happen. So if you want, we could just push another couple inches through of this strain relief, make the green ground wire longer than the hot or neutral, and solder it back to chassis ground. I have the big iron for doing that. Somebody has redone your power transformer HT center tap ground and jumpered it to the old ground. Not sure why we've got so much ground solder going on here. We don't need it. They also, actually, this is not the original power transformer. You probably knew that. I didn't look at the underside yet. Maybe we should take a quick peek at the big hardware. See what we're dealing with. Okay, yeah, so we've got a Hammond power transformer from, I don't know the date code on the Hammond here, but it's obviously a replacement. This would have been a Schumacher with the 65 date code on it, like these ones. So output transformer, correct, 65, 39th week. Choke, also 65, 39th week. And something else I like to do at this point is just check all this mounting hardware to see if it's in danger of falling off. And here's your bias pot, which we also need to make sure the nut on the bias pot is super tight too, so that it's making good ground. But let's check this output transformer. Yeah, not only is it a hair loose, it's spinning a bit. That one's good, but this one is sort of lost its purchase in the metal. These are just machine sheet metal screws that make their own, like they're self-tapping. And maybe this has come in and out a couple times, or someone used too wide a screw at some point, but that is a little loose and could possibly cause some stress there. We could try swapping a screw with the doghouse cover. We might get lucky. Choke's good. Tube sockets. You don't have any tube shield covers either, which is, especially if you're taking this thing out on the road, you probably want the tube shield covers for protection and noise rejection on a stage with tons of lights and weird power and stuff. So anyway, the sockets are tight. 6v6 sockets are tight. Rectifier sockets are tight. Rectifier pins are super not tight though. See how much play we've got here? Even with this bear trap trying to hold it in, which isn't stock, so somebody's added that because probably of how loose this is. But look at how much play there is and how easily it pops out. So, you know, these hang upside down and that can sort of vibrate its way loose and then everything goes down. So we will try to retension the sockets. I can show you really quick. So right down there, there's probably still some live voltage waiting to bite me, so I'm not going to stick anything in there yet. But you can see how each socket has sort of 3 little angled pieces of metal that grab the tube pins. And those have been sort of splayed out over time and are a little bit weak. So if you very carefully go into each one, tighten them closer together a little bit, then it holds the, not only does it hold the tube in, but it makes the contact so much better and stronger. And probably we're going to find the same thing on the 6v6 sockets. Preamp sockets don't take as much abuse, so might be fine. Check, make sure that's still on screen here. Yeah. Hopefully you're seeing everything I'm doing okay. But we'll put the rectifier back in for now. But yeah, that is not tight enough. Check the 6v6s real quick. So that's better, much better. Maybe just a cleaning. Now we did have a bit of noise earlier that seemed to go up and down with the volume pot though, so would likely have to be not the 6v6s, so or the phase inverter really. So both preamp tubes. They might share a cathode. I can't remember on the non-reverb version. Anyway, so that's the bottom side. A couple things to think about. Actually, what am I talking about? We got to look under the doghouse, see if it's been recapped and what kind of shape they're in. I'm sure it's been recapped if you've been gigging it and there wasn't a ton of hum, because those originals are usually pretty far gone by this point. Okay. Oh. So, unfortunately, we've got the world's worst capacitors in there. IC Illinois capacitors, which are like notoriously, literally the worst and the cause of many problems. Second of all, we got some wrong values in there. Third of all, actually, no, not third of all. The actual work done to put them in is very clean and good. It looks like they actually went in and maybe got some leverage on them. Didn't just, a lot of people will just clip the old ones out and attach the new ones to the old leads. It's just not a safe, sturdy enough connection for an amp like this. So I will double check the non-reverb schematic, but I'm pretty sure this is supposed to be 16, 16, 16, 16. But let me grab schematic and check. Okay, so here's the Deluxe amp non-reverb schematic. And you can see there's your rectifier, which is GZ34, which yours is. It's a 5R4, but pretty much the same thing. It's not the 5E4GB lower version, but there's your first reservoir filter cap, 16, and there's your other three, 16, 16, 16. So they've upped it to 47, which, you know, is going to change things. It's definitely going to stabilize your V plus a bit and smooth things out and be less hum, but it might feel a little different, and it might, with the GZ34, it's okay to have that high. Well, we'll measure it, but you wouldn't want to go beyond 60 or so, whereas the other rectifiers for Deluxes, the 5E4GB, you don't want to go past 40, but you're safe here. If we were going to recap it, because those IC caps are just so bad and likely to fail soon, I would probably just go 22 there and 16 everywhere else, just to get it more like stock, and use F&T caps that are going to last for 25 years at least. Okay, back to the amp. Okay, so that's pretty much the tour of the top side. So rectifier tube socket, possibly this transformer mounting screw, some tube shields, check into the 6v6s, find out if one of these preamp tubes is crackling. I would say recap the power supply, because these caps are just notoriously bad. The values are okay, but not classic. So, you know, you can decide to do that at any point, but hopefully do it before they catastrophically fail. So I will put the doghouse cover back on, and we'll flip it over and take a tour of the inside. Sometimes if you, like, I think these are 8, and if you get a 10 sheet metal screw, it will bore out a slightly larger hole for the larger screw as you put it in, and it'll grab again, give you some purchase to hold this transformer in tighter, because right now it's just spinning freely once you pass a certain threshold here. It's in a good spot right now, but that's, you know, pretty temporary. Okay, let's take a peek. Okay, so this is great that we have all of the original blue molded Ajax caps where they're supposed to be. These are the original trim ceramics. I'm not sure if that's an original Roach. They're usually closer down to the board, but, you know, no big deal. The cathode bypass caps have been done. I don't know exactly when, and they used 22. That's totally fine. Your treble cap here is original, and your treble cap here is original. And your bright cap on the normal channel has been taken out, which everyone does, recommended. The screen resistors have been replaced with big dog 5-watt 1Ks. Normally these are 470 ohm. Probably fine and safe and pretty serious wattage there, so they're not likely to fail, but sometimes you'd rather they fail than your 6v6s, so we can think about that a little bit. You know, the wiring in this is a little, I've never seen exactly this slightly stiff braided stuff. Cloth covered stuff. It's usually a little more supple, and the lengths are usually trimmed a little tighter, but I'm sure it's original. Just haven't quite seen this exact variety before. But yeah, a lot of these look to just be original joints. This stuff not so much. Heater wires all looking good. Your 6v6s do have grid stops on them, 1.5K, which, you know, like the AA763 about a year earlier, these weren't in there yet, so this is more confirmation that it's 65, and then there's the chassis stamp that seals the deal, so 65 there. And pot date codes, bias pot here says, yeah, 65, 42nd week. So it's definitely a 65, maybe sold in 66, who knows. So let's take a, I'll show you the, from the other angle, because a bit of work's been done back here. So your bias cap has already been done with a very good F&T cap. Those are the ones I was talking about doing your power supply with. So that's gonna last forever. It's a voltage, it's a capacitance and voltage rating that's way overkill, but there's probably no downside to that. I mean, very subtly, the bias might be too stable when you're trying to drive the amp into, you know, super overdrive. It won't sag as much. It'll keep pulling the grids more negative and won't go into conduction, which usually this is what you want. So I would say you're fine there. But yeah, because of this power transformer not being stock, there's no heater winding center tap, so they've made an artificial center tap for your heaters here, which is totally normal for, you know, Deluxes in the 70s when they stopped having power transformers with heater windings center tap. It's actually maybe a little easier to get the amp quieter without hum from the heater windings, and it's safer for your power transformer, because if there's overcurrent through them, instead of burning up the heater windings, it'll take these resistors out, and there's, you know, 50 cents worth of resistors there instead of $400 worth of power transformer. So I would say this is a good thing, even though not stock. Soldered right to the chassis, same place that the bias cap gets grounded, which is good. So yeah, here's that close-up of the slightly strange situation for the high voltage center tap to ground. Not sure why they didn't just go here again, but no big deal. It looks like a good joint. We'll stress it and see if it wants to pop or anything, but I think it's good. So this is original filter cap ground, and your bias pot gets its ground through the chassis. that nut on the other side that we didn't check. We should check that because there was a bit of loose hardware going on. So then we get to the replaced tremolo intensity pot. And I am going to have to figure out exactly what they've done here, because just from looking at it I can't quite see, but it does explain why the rotation on this pot isn't standard. It might explain, once we dissect the circuit a bit, why the trem is not exactly what we'd expect, like a little stronger. Maybe that's a good thing, so maybe we just leave it. The rest of these pots, let's get some light back there for you. The rest of these pots look to be original, although these ones aren't CTS. These ones are the trem speed, and that must be treble. Yeah. Trem speed and treble pots are CTS from, let's see, it says, date codes are covered up by the solder blobs, unfortunately. Oh yeah, those are 65. 20th week of 65 for these CTS pots with the codes written on the shell, on the base, the bottom of the shell like that. And the other pots, forget the manufacturer, but they would be stock as well. Yeah, also from 65. You can see the date code right there. 19th week of 65. Bouncing around here, sorry. Okay, let's put you back on the tripod and keep looking around. Okay, so we've kind of established that there's some curiosities about the intensity pot and circuit. The rest, I don't see any circuit changes. So we could just take a few measurements, light it up and measure some voltages. Input jacks look okay, just a little dirty inside the chassis here. Probably somebody's been spraying something at some point, but we'll clean all that up and get the little solder blobs and stuff out. And then we'll just check a few voltages, make sure everything's good and not leaky. Like, we can check into these coupling caps and cathode bypass caps to see if there's any leakage yet, but I don't think, well, yeah, we'll check those cathode bypass caps. Okay, so I'll get some meters hooked up back in a sec. Okay, so we've got the meter hooked up. We've got an 8 ohm dummy load in place, so your speaker doesn't go when I start probing around voltages. And let's plug it in and light it up and see. We'll also check the bias with the bias probes, which maybe I will attach right now, actually. See where it's currently biased at. Six V6 number 1, 6V6 number 2. Okay, so we got our bias probes and our meter. Let's get this lead freed up. And let's power up. One other thing that I was looking at is on the wiring for the AC. So not only is that ground too short, but it's also not following the standard currently recommended procedure of hot. First of all, hot is going to the neutral pin on your courtesy outlet here, the wide pin. So hot should be going here to the narrow pin, and white should be going to the neutral on your courtesy outlet. And then currently they're just using the switch, the ground switch, as a landing place for wires. There's no actual switching of anything going on, but they've got the hot coming up and over to here, which is fine, and then going straight to the switch, the power switch, instead of through the fuse. So typically you should go hot to the courtesy outlet, to the fuse tip, then to the switch, and then onto the power transformer, primary, one of the primaries, and the neutral should just be straight to the other power transformer primary, instead of what they've got is the neutral being fused through to the power transformer. So if we're going to do this ground again anyways to make it longer and safe, we should also switch the polarity on your courtesy outlet, so if somebody plugs something in there, it's not backwards, and fuse the hot. So your black wire would get jumped to the fuse tip, then over to the switch. And standby is not part of all this. Standby is done correctly. And then the neutral would come from the correct pin of the courtesy outlet straight to the power transformer, which also frees up your ground switch, which could then be used as a negative feedback bypass switch to give you like a nice crunchy gainy sound without tons of volume, and it's just on a switch. It's almost like a raw pedal boost, a little bit of a boost and a little bit more gnarly tone that Fender was trying to dial out by adding this negative feedback resistor here. So we would take this wire that taps your speaker output and sends a little out of phase back into the circuit to calm things down, instead of going straight here. And it's nice that remember I was talking about how these wires are a bit longer than in most amps? I think we've got the length, once we desolder here, to take it straight to this switch. And then I've got some more yellow cloth covered wire to take it from the switch back to the speaker jack, so that this switch would then switch in and out this 820 ohm negative feedback resistor with, all you'd ever need to do to put it back to exact stock would be remove the wire that we added and bring this wire back to over here, solder it on, no fuss, no muss, totally reversible, and then it's a nice cool little easy little tone change for you. Anyway, let's look at some voltages. So we can see on the plates that we've got 420 volts on your 6V6s, which is exactly correct for the schematic, but we only have 12 milliamps current on each one. They're very balanced, which is awesome, and probably why there's no hum. But that's very cool bias. So that's 5 watts per tube. So older 6V6s like these are typically 12 watts max plate dissipation. And everyone, you know, the internet likes to bias things a little hot at 70% of max plate dissipation, which is, you know, about like 8.5, 9 watts. And at 12 milliamps, this is biased at 5 watts, so quite cool, less than 50%. Probably would not have left the Fender factory less than 50%. So we could bias a little hotter and not hurt your tubes and have a little more overall level and a little more maybe touch sensitivity, and I don't know, as the bias comes up everything just gets a little juicier, but if you go too far then it's taxing on your power tubes. But we're a long ways away from being taxing on your power tubes. So if you wanted, we could up the bias to, you know, 60% or something instead of in the 40s, which it is right now. Hey Siri, what is 40% of 12? She's not answering. Hey Siri, what's 40% of 12?
40% times 12 is 4.8.
Yeah, so we're just over 40% at 5 watts here. So I would say that's a very cool bias, and you can afford to bring it up, see if you like the tone. Sorry, my phone ran out of space there. So measurement wise, that is fairly cool bias, like probably too cool. Another thing about it is that plate voltage on the schematic is 410 and we're at 420 once we get some current drawing. And if we bring the bias a little warmer, back to sort of what normal would be, not even like pushing it or anything, then I bet the voltage would land at about 410, which is what the schematic calls for, which is basically perfect. Checking the voltages on the plates of the preamp tubes, we've got 165 and 155, which is just a hair low, but pretty darn good. You know, these voltages in here are plus minus 20%, so we're well within that spec. On V2, 175, 189, that's also great. I can't remember if before I ran out of space I showed you this, but this resistor, the slope resistor on V2, has been changed, so it must have been noisy and somebody swapped it out for a metal oxide instead of carbon comp, which is, you know, okay. It'll be quieter, but it won't be quite the same. Probably negligible though. And you can see we've got no leakage on these bypass caps. And we've got no like negligible DC leakage on the board anywhere. Sometimes the actual board, the eyelet board, becomes conductive because it absorbs junk and moisture and stuff and becomes conductive itself, but this is pretty clean. I'm not seeing anything more than 50 millivolts, which is totally within reason. The cathode voltages should be right on 1.5, 1.6. Schematic calls for 1.6 there, so we're good. So I think we should now, we're gonna plug the speaker back in and see if we can figure out what's going on with those 12AX7s possibly being noisy. Hope it's that, and we don't have to dig any deeper into the circuit. If it is, then we can swap them out, or you can just live with them if you like how they sound. The noise is subtle. You have to really crank the inputs to get it to appear. So We'll just see. So speakers plugged back in, powering up. And volume up. Not microphonic really, I mean a bit, but I'm pinned, so you'd expect about that much. Much quieter on channel 2. That's just phone garbage. So yeah, that's a little bit of hiss there. I bet if I swap V1 and V2 that the hiss will follow. So let's see. First of all, let's see what we've got here. Soptech and Philips. Okay, so Soptech's going into channel 1. Philips is going into channel 2. And we'll power back up and see if the noise followed. You know, one just has a lot more hiss than the other. So here's channel 1 with the tube swapped. Sorry, still warming up. Sorry. Got your upside down power switches throwing me off here. Okay. So channel 1 is still hissier, which means it's got to be most likely one of these 100K plate resistors. It's quite microphonic to the grid input there. And just this manipulating of the wires has an impact on the hiss. Very microphonic. Wire itself. Over here, the grid on 2. Much less microphonic. So it could be that grid wire itself is unhappy, or the slope resistor, or its proximity to the slope resistor. Although I think just manipulating it a little bit, that's definitely too much hiss. And that sounds like resistor hiss to me. So likely one of these 3 100Ks. And, you know, we can measure them and see if one of them's way out. It'd be the clue that it's that one. But that's where that hiss is coming from, not the tube, which is good because those are both good tubes. We like good tubes. So maybe I'll stop there because I think we've sort of not solved, but identified everything that may or may not be going on. And just to recap, summarize that is, I would say I'd like to clean up this AC wiring. Longer ground, hot going where it should, and to the fuse, then to the switch, neutral going to the right place on the courtesy outlet to the power transformer. Freeze up the ground switch, bring the negative feedback over to the switch, so it's switchable negative feedback. Bias slightly hotter, get the plate voltage down to spec. I just cleaned off camera your treble pot all the other pots were good. So now all the pots are good, no noise. Clean up the input jacks just while we have it open, and speaker jacks, and then go around and tighten the input jacks and stuff like that, just to make sure grounds are all good. Then rectifier tube pin sockets, socket tightening, maybe similar on the 6v6s, but maybe fine. Figure out which of your 100K plate resistors needs to get swapped out, which, you know, may or may not bother you, but it is hissier than it should be on channel 1, and it's 99% sure that that's the cause. And probably recap the power supply, get those IC caps out of there, and maybe find a new screw for your output transformer mount. And then this thing will be pretty much as good as it can be, which is pretty frickin' good. Okay, talk to you soon. Well, yeah, last thing would be the deticking the tremolo. So that's your tremolo roach, little neon bulb in there that flashes. And if I add a 10 nanofarad cap across the roach from here to here, then that ticking usually gets taken care of without any impact on the signal path at all. So there's no effect on your tone, it just takes away the tick. So I'm going to tighten up these input jacks and get rid of a bit of this grossness. Yeah, somebody's been spraying cleaner in through the jacks and stuff, so we'll clean that up. All contributes to a little noise, and, you know, a little solder blob flying around in there lands in the wrong place and crackles and shorts, so we'll get it cleaned up. I'm gonna get in the shorting jack too. That's what keeps your input quiet when nothing's playing. When nothing's plugged into it. So this tab here shorts the tip to ground when there's no cable inserted. And then, you know, when I insert a cable, it lifts that tab. And this is no longer making a connection to each other anymore. And sometimes in between there it gets dirty. So we open it up, insert a little strip with the oxide on it in between the two posts. Come on now. There we go. So that little strip has some cleaner on it, and then we pull the jack out, clamping them together, and then as we give it a pull, it sort of gets it nice and clean between the two, and you can see the little bit of grime that it pulled off of the contact point. So we'll do that to all of them. Okay, as you can see on the low input here, the tension for the shorting element is not very good. Like when I let go, oh, it just barely makes contact. It is making contact, but it's almost not. So we definitely want to clean this one and maybe retension it. It's a little bit of a tricky job retensioning it, so you don't want to bend the metal in such a way that it adds to the fatigue of it. Let's trap that in there. And give it the pull and see. Yeah, so didn't really come up with anything, but maybe that's because the tension is so low between those two. So yeah, that's something we could do. So now we're on the vibrato channel and the tension's here. Good. Nice and strong. Good shorting. And on the low input, same. Good connection. We'll just clean them out and they'll be fine. Okay, that looks a lot cleaner. Not so much junk laying around. Okay, what do I see here? As I was cleaning. Hello then. Where does that wire go? Sorry, I lost it on the camera. Where am I? Yeah, there. Let's see if we can find out. Well, we certainly don't want that floating around in there, do we? That's like a clipped resistor lead or something. That shot back into there probably when this recap happened. So, you know, you're trimming up components and then something flies back there and you heard it, but maybe it hit the ground. I don't know. Anyway, that's good. You don't want a chunk of wire like this floating around your amp. Like, watch. This could just end up anywhere, short in between anything, and blow something up. Got him. Okay, we got another little piece of something in here behind these input jacks. Might just be some insulation from a wire, but it's not supposed to be there. It's tricky to get though, especially while holding the camera. Especially when you're holding the camera in the wrong place. Okay, so yeah, there it is. I can free that up, I think. Gotta move this light a little bit. There it comes. What are you? Are you conductive or just a little piece of insulation? Anyway, got him. Don't want him. And his little buddy is back there too. Yep, got him. So yeah, more things that we don't want in our amp. So I went around and I tightened the nuts for the speaker jacks and the input jacks to make a really good solid contact with the ground, and same with the vibrato pedal. And last thing I like to do there for that is tightening or checking the power transformer mounting bolts, which because of the weight of this thing often sort of get a bit loose. And I'll tell you already, they were a bit loose, so they're easily taking a half a turn, another half a turn. So I'll make sure these are solid. I'll put the camera down to do it. Yeah, you don't want this transformer going anywhere. Okay, nice and tight. So I think I'll stop there, even though I said I was gonna stop earlier. Just wanted to get that stuff done for you. And you can let me know if you want to go on and do the other stuff. Okay, cheers.